So in the earlier sessions, we covered, right, the BRYCK platform basically enables the customers, edge customers, to collect a lot of data and process and move. Now, with the interest in AI is exponentially growing, all these edge customers want to process their data, right, with AI algorithms for instant decision making for the edge data. The challenges are as follows. So today, they can do edge AI processing they're doing it, right? Some customers are doing it by sending the data from edge to the cloud through whatever network they have and get the data processed and then get the result back and then do decision making, right? That's one kind of AI processing workflow from edge. That's becoming challenging now because not all edges are connected to network, number one. Number two, the amount of data that gets collected in the edge is exponentially growing, hundreds of terabits of data, sending all of them to the edge and then getting processed is impractical, right? So then the edge AI processing is moving to the edge. Technically, you can go and build this AI infrastructure at the edge by installing traditional system like GPUs and so on. But that's also a big challenge because edge computing systems, edge systems are very stringent, special designed systems. You cannot go and add a GPU in it. You can't add a general purpose AI processors in it. So that is another big challenge on AI at the edge. So with the BRYCK AI, so we addresses these problems easily as follows. Customers use BRYCK to capture data today. And with the BRYCK AI, what we do, take the BRYCK, and in addition to the storage capability inside the BRYCK, we also add the AI capability, AI processors within the same BRYCK. And without changing anything in the infrastructure, customers' edge workflows gets this AI processing capability. Right? They don't need to go and put the GPU because there's no way to put GPU in it because the systems are not designed for that. It doesn't have PCI slots and so on. So the advantage of the BRYCK AI is, so it has this data in it, and then it has a capacity, AI capability, everything built in together. And since both the data and AI in the same PCI infrastructure, you can process a large amount of data really high speed. Very high speed. And as a design goal of the BRYCK, it's a low power system. And the AI processor engines, right, we built in within the BRYCK are highly power efficient. Compared to GPU, it consumes fraction of power, which automatically enables various edges to deploy this BRYCK AI to capture data and do AI processing without connecting to the network, without connecting to the cloud. It provides this huge capability for all edge use cases, this AI processing.
You're not doing AI training.
So in the initial focus is AI inferencing. And the AI training workflow requires massive GPU infrastructure. It typically happens in the cloud. That's done by our previous workflow, which is like BRYCK carries the data to the cloud and they do it. This is for edge inferencing. After you have models, and then deploy it at the edge. It could be any edge. It could be a manufacturing plant or a data center or autonomous vehicles, right? You can deploy, and then you can apply the model and get the data.
And the compute platform accesses either the AI, either the inference or the base storage equally over PCI?
Equally. So it's for the computing system where it connects to, right? This BRYCK AI. It sees both the processing engine and the storage.
Are they distinct volumes, or is it how is that handled?
So the amount of data and the amount of processing capability, right? So the BRYCK it's configurable. So when you order the BRYCK, you would say, I need this much storage capacity with this much computing capability, AI processing capability. That's what you get it. And then the BRYCK AI platform comes up with extensive AI software stack that comes up with the pre-trained models, popular models, pre-trained, and then you can deploy instantly with the data. Or customers can bring their own models developed using standard frameworks like TensorFlow and so on, take the models and compile it within our platform and run it with the data. That's how it is done. The BRYCK AI platform comes up with several advantages. I said one is power efficient, it's highly parallel, it's powerful than a typical NVIDIA systems because architecturally BRYCK has many components, right? As a storage, AI, many AI chips, we can do things in parallel, operations in parallel. And this is a PCIe Gen 4 high-speed architecture. You can have both the processing and the data going at full speed at the same time.
Have you run benchmarks against NVIDIA?
We have run benchmarks against NVIDIA solutions and other cloud solutions. We are like 10 to 20x faster.
Are you going to show us the results of that?
Later, not now. Yeah, not instant. Yeah, it's progress. Yeah, that's that. As I said, software stack is another biggest value here. So customers can deploy their own models, compile the models. A data scientist can write AI programming with the SDKs, APIs included in the BRYCK AI platform. So the BRYCK AI, both the storage and the computing capability is configurable. That's the advantage of this offering, because in some cases, customers would need a lot of data and some minimal number of compute needed to process the processing. Some use cases could be heavy compute processing, AI processing on a smaller data set. The BRYCK AI provides this configurability, right? That's one of the biggest advantage for the customers. And second advantage with respect to the throughput, today, customers deploy GPUs and various high performance engines, right, for AI processing. Most of the time, we see a significant bottleneck in this all kind of GPU workflows, because the GPU is capable of dealing with a lot of data, but the data has to come from somewhere, typically from network, some centralized storage. That's where the data comes from. We see significant bottlenecks there. The GPUs are underutilized, only 30-40% utilized in most of the deployments because of this data throughput bottlenecks. With the BRYCK AI, you don't have that problem because both the data and the AI processing sits next to each other in the same PCI bus infrastructure, so you can access the data at high rate for AI processing.
What happens if you have multiple bricks that you've been collecting data? Can you use them in parallel, or do you have to move all of the information to one brick before you start?
So with the BRYCK AI capabilities, you can what we call composable AI. So you can add brick 1, brick 2, brick 3, and then the compute capability linearly scales.
So how does that work with your docking system? Because from what I understand, you have a dock basically, and you put one brick on the docking system. How do the docking systems get connected together?
So the way the docking system connects to today a computing system. Today, that's how it connects. A computer, a server, right? That's how it connects. So each brick today it's connected to a computing system. It could be a server, it could be a edge computing system, it could be anything, any computer, right? It connects to. Now, the software layer which runs on the computing system, it connects all the bricks, right? That's how that has a distributed connectivity algorithm. All these systems connect to our network, high-speed Ethernet, 100 gigabits Ethernet network.
Okay, so it's not a standalone AI inferencing system. It has to be connected and relies upon the connectivity of the fastest, basically, component, or slowest component dictates the speed.
It has to be connected to a computing platform, as it is with a GPU too. A GPU is not a standalone, right? GPU is a very popular AI processing engine. It's not a standalone system. It has to be connected to a computing system. GPU is just an accelerator, right? It just accelerates AI workload. The same way BRYCK accelerates AI inferencing workload.
So this is not actually a BRYCK AI platform. It's a component of an AI platform.
This is a component of AI platform. Yeah.
So I like to say that there's no such thing as an AI application. There are AI services that get incorporated into applications, and that even something that you think of as AI, which would be like a chat, is really a chat application that uses AI.
Yeah.
And so this looks like a proverbial plug and play AI service within some other system.
Yeah.
Obviously a system that needs to perform at the edge.
Yeah. So there are two models, right? As a company, what we call this is a BRYCK AI platform. So BRYCK is one component, but as a solution, we ship BRYCK, tray, and the server, compute, right? So we ship together, all of them together by default. In some cases, customers say, hey, I have a computing system designed for my applications. I'm already running in my infrastructure. In those kind of cases, we connect the BRYCK to that system and run our software there. Still, it's a platform. It is the computing layer. It comes from us most of the time. Optionally, customers can use their own computing system.
So is the advantage of the BRYCK AI the fact that the GPU is directly connected to the storage over the PCIe bus internally to the storage box instead of through the server? So you're able to leverage more lanes of PCIe.
No, not only that, that's one advantage. In a typical deployment, if you take any typical deployment where a server with many GPUs, right? That's a typical deployment.
Right.
So the data that needs to be processed is not within the server. It's coming from somewhere, most likely a centralized
It's coming
storage.
over the network.
Coming over the network.
Right.
That's where we see significant bottleneck there. So that because the data rate is not able to feed the capability of the GPU engines, and typically in typical deployment. In
So
some
you're-
cases they optimize. The typical deployment is like that.
So you're eliminating the network bottleneck.
You're eliminating
right?
bottleneck
Connecting
because
a high density storage
Yeah.
direct connect to a GPU.
yeah,
Now that still has to, just like any other AI inferencing engine,
Yeah.
that still has to live on a server somewhere too. That's the master controller.
no, it's
Of
not
the-
server. In our case, it resides in the BRYCK. The AI
The GPU resides in the BRYCK. The
Yeah.
BRYCK plus GPU resides inside a server
yeah.
that's controlling the AI up that tells the GPU what to do, right?
No,
Run this
I don't-
program.
No, in our case, no GPU, only BRYCK AI.
So
In our deployment, GPU is eliminated, right? Completely there.
just
But
to simplify,
external GPU is eliminated. You're using some sort of XPU, whether it's GPU, TPU, whatever it may be.
You have
sort of
something inside
internal
the box,
platform,
right?
Yeah.
presumably with
Inside
a CPU-based
the-
orchestration
Yeah.
to affect the AI. You're making a black box of AI.
Yeah.
But so external GPU not necessary.
No,
here.
right. But the external server is necessary.
The server is necessary.
You
Yes.
still need to host the application.
So no, so that's the application.
A server will host the
Clear.
application.
Yeah.
Right. So that's a typical any AI that's AI architecture. Computing is needed. CPU is needed to offload the AI
Yes.
workload to a processing engine. The difference with the BRYCK AI platform is since the edge focused. At the edge, we don't have edge computing system. Typically, don't have many PCI slots where you can populate many GPUs. You don't have it, right? Either you have to change the infrastructure to accommodate that, or you can use the BRYCK AI, which is already connected to the system, which is storage connector already connected, and then you can leverage the processing capability within the BRYCK.
What's not clear, at least not yet, is what's going on inside the BRYCK as far as the AI processing platform
think
portion goes.
Yeah.
You're comparing to NVIDIA. That implies that you're not using NVIDIA inside, but maybe you are. There's how much high bandwidth memory you may be using, what you're doing on chip, what's offloaded, that sort of thing that can affect performance and what types of AI services you can implement on it.
Correct. So this is a AI inferencing engine. That's what we call today.
Yeah, it's
right?
inferencing only.
Inferencing only.
It could be all CPUs. I mean,
Yeah.
you can do that.
You can do that, but the study shows the amount of processing needed. So the CPUs are not capable of handling like a huge data. A typical simple single video computer vision workflow, a CPU may be enough. Here we are talking about a data that's involving hundreds of terabytes of data. You need CPU is not enough. CPU is just an uploading engine. So you deploy an application where it receives a stream and deploys in the AI engine in the BRYCK.
yeah, just to add and simplify.
Yeah.
So as we are using flash chips inside, similarly we are using AI accelerator chips. There are companies who are providing AI accelerator chips in U.2 form factor and
FPGA or
M.2 form factors, which currently servers like Supermicro servers can put one or two. We can put many because of our architecture.
So is the BRYCK architecture really just doing RDMA into the system? Is that all we're really doing? You're taking the GPU outside?
We're doing PCIe. It's
Yeah,
not-
it's
not-
PCIe. So
Conceptually, you can think of BRYCK has up to like multiple tens of GPUs inbuilt. Think of that way.
So
Right.
just to simplify, there are slots here where you can
whatever you
put
wanna call it.
flash chips and you can put accelerator chips, and you can combine any numbers. You like we were mentioning, you can do complete AI chips of 64 teraops, or you can do 400 terabyte and around 208 teraops. So you can configure number of chips designed in this platform.
I think that
So I want to clarify this one because audiences, I want to see that. Did we get it? What BRYCK AI provides?
It's critical right now with how quickly these models are developing and what sort of deployment scenarios customers have. Generally speaking, it's critical that they understand the infrastructure that it's running on. And so hence the questions.
So question comes. So,
right? There are lots of available options for AI inference. It's not just the standard GPU, CPU.
Yes.
Or the best known CPU or GPU platforms. But like I said, like there is a fair amount of interest in how the inference is going to be implemented.
True.
So it's AI.
Not just you're promising outcomes here. And there's an assurance in knowing how you achieve that outcome.
That's right. The AI industry is evolving. Customers, they want to do AI processing, but most of the time they have to go and learn and do it, right? So it's not like plug and play deployment, just happens most of the time. But there's a huge innovation is going on. A lot of applications are coming up. For example, we have qualified with the BRYCK tens of different AI applications transparently deployed. We can deploy it. I'll talk about all the use cases. So we have applications already deployed in this, which is plug and play deployment. Some workflows which requires a custom AI processing, where few data scientists sit together and write the programming and write the model and so on. That's also a typical workflow. Even that workflow also supported with the BRYCK platform because you have an extensive API list available for data scientists or programmers go implement their own AI programs.
I think it would probably not surprise you that you're not directly providing us data on what accelerator you're using is giving us some confusion because you're comparing directly to NVIDIA. And so if you're comparing to an accelerator, it would be nice to know what accelerator, and then is the accelerator driving the performance delta, or is there something else unique in this box that's driving it?
I can answer that. So typically we are agnostic to any flash chips. We can use Micron, we can use WD, we can use Toshiba, we can use any. Similarly on accelerator chips, companies like we have qualified Hello, which is one of the companies who provide the best performance today. There is a company called as DRAM. There is a company called as Kinara. So these are the three major companies who provide accelerator chips in M.2 form factors, which we are using.
Got it.
So we are not. So it's as Sahil pointed out, the platform is agnostic to AI accelerators, right? We pick the accelerator which meets that particular workflow. Now, comparing that with an NVIDIA equivalent. NVIDIA Jetson, I think. Jetson is
Jetson, Orion, and Xavier.
These are the inferencing engine, inferencing chips, right? We are comparing that apple to apple. The second biggest advantage compared to a typical NVIDIA system is this system, you can populate as many such AI chips as required, as your performance demands, right, in this, right? So to achieve the desired operation processing, that's another advantage as over a traditional inferencing system. And then third thing is, now you have data and AI engines are sitting next to each other. You can stream the data, pull the data, read the data at very high speed and get it processed done, right? That bottleneck is eliminated. Like that's the advantage of BRYCK AI platform compared to traditional, traditional AI inferencing deployments.
Yeah, typically you can't use RDMA for something.
Well, no, I'm really getting at is it appears that it's explicitly giving you an external way to get into the bus. We have a high-speed bus that we're expressing.
I'm not convinced it's running on PCIe inside the box. I know it's a PCIe interface. I didn't really hear that. Is it?
It's a
PCIe inside the box.
It's a
5, right? 5.
It's a PCIe 4.
4.
PCIe Gen 4, which is pretty high. And we have so many devices in it. Your throughput is like hundreds of gigabytes per second. You can access both data and AI processing at the same time. So just to summarize, the advantage, value proposition of BRYCK AI is you have highly parallel processing. You can dynamically configure the processing capability you need, like number of tera operations you need to address your workload. And then the data and AI chips are sitting next to each other. There's no bottleneck to pulling the data over network for AI processing. That means you can process large amount of data quickly. And edge infrastructures have fundamental limitations. You can't go and deploy a traditional data center server to add AI chips to it. It's not possible. There are already systems designed with the limitations. You cannot go and add 10 GPUs to it or 10 NVIDIA Orient to it. You can't do it because of the limitations. With the BRYCK AI, you don't have that limitations. BRYCK AI is already connected as a storage layer to the edge infrastructure. Now you can store the data and process it. That's the advantage. Okay.
So just a question on the, sorry.
Yeah, please.
Just a question on the thing. So you buy a brick,
Yep.
and I can imagine it's not cheap, okay? But it's configured a certain way.
Yeah.
I cannot reconfigure that. So if my application changes or my demands change,
Yeah.
do you have a trade-in program for the old brick and you give me a new brick, or how does it work?
Yes.
Yeah.
Yeah.
So on a business model, we have a leasing model where you can lease it for 36 months, 24 months, and we can give you upgrades. Like today you buy 128 terabyte, you want to upgrade to 256, 512 or a petabyte. And in rental model, it's monthly basis rental where you rent it for specific use case like project for 6 months. And then if you buy upfront, there is a instructing value of the write cycles and read cycles based on your usage. We can upgrade the 512 or 1 petabyte as well going forward.
As well as the proportion.
It's like leasing a car or buying a car, you can trade in with the value of the brick.
Because when you describe switching out slots for the compute versus storage inside, the AI inference versus storage, that's in configuration at the factory.
Yeah.
And it's delivered and it's fixed.
Yes.
But you have these ways to,
ways to
like you say,
and we have a
life cycle.
It's a forklift.
Yeah, and we have an open architecture also where we don't port it. We give it to you for data centers, like environments which are edge but not harsh edge, where you don't need a military grade. You can configure and change as you want. Like as you grow your applications in a year, you want to change capacity, you want to change TeraOps, with the same system we can do it.
Okay, so hang on. So you have one which is military grade, which is hard and you cannot get into it.
You cannot get into it.
But then you have another one which you can actually open it up and swap components in and out.
Yes. That's the data center version what we call. It doesn't demand this ruggedness, right? Because it's mostly the system is sitting in the data center. So the system that moves for a security purpose, so the customer can choose these options.
Okay. But like, for instance, if the whole original purpose of having the brick is to be able to move data. So I want to store my data off-site. So instead of putting on tapes or whatever we used in the old days, you now put it on a brick.
Yeah.
Okay. But I also don't want that truck taking it to the off-site storage device to get hijacked and get into it and be able to take my data out.
So that's how we built this architecture. If you see, the reason we were not doing an open brick is we don't wanted to give an accessibility to inside components. But when you see the customer use cases, when you scale, they want to keep certain data. They don't want to take data out of the brick, but they want to keep in data center environments. So that's the reason we have 2 brick architecture. We can build 3 bricks, 4 bricks in the same, where you have 1 brick which is rugged. You can move that, use for movement, and 1 keep it there, because brick to brick copy is fast, brick accelerator, rendering processing. So nobody wants to, I would not name the storage companies, but nobody want to move the data from brick out to their primary or secondary storage. They want to keep this as it is. But that uses are not movable uses. So we thought we'll give an open brick, which is we call as a non-ported brick, where you can change the component, accelerate the component, increase the life of the product as well. And on the rugged size, where you are doing movement, you are putting in different locations, that is the military grade.
You got 1 portable version and 1 non-portable version.
Version.
Same form factor though.
Same form.
Same shelf.
The data movement is one of the biggest value prop, but another biggest value prop is the density and the throughput, right? You store a lot of data, you can access at really high speed, and that value prop applies to even a standard data processing use cases in the data center, right? In edges, So sometimes the data sits there, resides there all the time. So, but customers want to have a flexibility later to exchange things and so on. So that's the two variables.
So how do you wreck the brick?
It's a rack-mounted system on the tray. It's a full depth, a half depth, rack-mounted system.
Yeah.
It's for you.
The tray adapter is rack mountable, so,
And you've
so you
gotta
can
have-
pull and remove the brick easily. Yeah.
And you've got to have that both at the edge and
Yeah.
then also in the data
At the
center.
data,
At the data
side.
have it.
yeah.
Yep. Yeah.
So your edge deployment's got to have enough space somewhere to handle a 4U rack or whatever. I guess, is that, when you're talking about this much data, that's probably not outside the bounds of what's normal.
It's not, so that's why we have two form factors. One that goes to racks.
Yeah.
If we look at autonomous trucks, right, they have a dedicated rack inside.
Yeah.
Planes have a dedicated rack inside. But some smaller edges, they don't have it, right? So, but there are single brick tray, which is very small, so which can, so it fits in various use cases.
And then the mini,
Yeah.
of course.
And
the mini
there are use cases which has still low space requirement than what we have as a tray. That's where the BRYCK Mini comes into picture. To address that small edge use cases, the BRYCK Mini addresses that gap. And you can deploy it in any smaller edges, even a drones, right? You can deploy it and then you can do the same.
So let me ask about the BRYCK AI.
Yeah.
Where the goal is, I think the use case would be in a situation where you have limited throughput or limited network connectivity. You want to do AI inferencing at the edge. You're processing massive volumes of data.
Yep.
Is it still, though, you still want to put in those use cases, do you still want that data to be portable? Or is it simply just you have an opportunity here with high-speed storage and high-density storage, and we can put an accelerator there and then enable that use case without worrying about the portability?
Both the cases are possible. So, and this AI processing in place, right? That's for instant decision making. They want to make a decision instantly. But eventually, the edge capacity cannot be grown infinite, right? So it has to limit. It has to go somewhere. It has to move. Either discard or move. In some cases, data is discarded. They don't care about the data, right? In some cases, they want to keep the data, keep accumulating it, right? So both workflows are possible. We see customers with both the workflows.
Yeah. And typically, if the edge is fixed, they want to scale. But if edge is like moving things, and we have seen the use cases into computer vision, natural language models, where drone is collecting a lot of data, not the smaller drones, but the large drones which are collecting data. So that's why we are building a different form factors like mini and block, which can go in this form factor. Our expertise is packaging the electronics into form factor, managing the heat and thermal, and building the software layer. So 60% of the component is software USPs which we are giving into the component. And I was just taking out the time and putting the slides of use cases. So agriculture, healthcare, manufacturing, government, security are the typical use cases. We have not described the success stories of government and defense because it's classified work we are doing. But a lot of use cases which we can speak openly and publicly is monitoring of interviews, monitoring of different bases, security, border security locations is what being used in the defense as well.
Yeah, so typically inferencing workflow is what they call computer vision. You have a lot of video and imagery data coming, and then you do AI processing. And that's what, so we have a lot of models already pre-built. Customer can deploy instantly. So on our other platforms, BRYCK AI, BRYCK Mini also comes in the same flavor, right? You can have a full storage or you can have a AI, built in, configured. So that the BRYCK Mini platform, you don't depend on the external compute. Everything is inbuilt, right? Compute, everything is in there. So models can be deployed from the compute within the BRYCK Mini.
Yeah. And just to add, in Mini platform, we are an inception partner with NVIDIA. We are using a lot of their stuff as well because the DPUs which they have built are excellent to deploy in the environments we are building is. So we complement to what of their platforms are. So one of the use case we complemented is inferencing is done in the BRYCK AI and then deployed on a GPU based on NVIDIA. So that's what we complement and provide value to them as well.
Yeah.
And we can connect offline, we can share the data, we can share the deck, we can share the data sheet. And on our website, we have put a lot of case studies, blogs, and use cases. and we are trying to make more use cases public, as this is more nascent state of our deployments. We are trying to collect more data. To give you an example of comparison between a typical GPU as well as accelerators in this, like maximum a single node system can scale up to 256 teraops and takes around 25 to 40 seconds depending on the use cases where you are deploying video data to distinguish between an object or a person or a weapon. We have deployed that kind of use cases. Then there is a use case which do a geographical data mapping, that application. So we have seen if typical GPU performance is 25 seconds of inferencing, our is 5 seconds. So that's how the difference typically is in the. We have benchmarks. We can share that as a case study.
Yeah. So one of the use case I'll finish then end. So in one of the use case, a manufacturing plant, it generates a petabyte a day, right? Petabyte a day. Suppose you want to do AI processing, and that petabyte a day, think about how many NVIDIA Orient chips you need to put in. There's no infrastructure to put there. NVIDIA Orient chip is not a plug and play deployment. It's a chip. Somebody has to go and build a system to accommodate that. So in the same use case, the petabyte data captured, the BRYCK AI platform can be instantly processing those data. Right? It can store petabytes of data. You have a configurable amount of AI processing capability, so you can process all this kind of data. So that's the extreme large data use case, and this is applicable to even tens of terabytes of data as well with the BRYCK AI.